All right, page 21, lesson 3. More about constant of proportionality. Again, yesterday I mentioned that this lesson I thought would go in front of the one we just did. We did do quite a bit. Remember, the number next to the 1 is the constant of proportionality. How much per one of something? How many paper towels in one case, for instance. So the first example here, just to get our brains going, says use the numbers and units from the list to find as many equivalent measurements as you can. For instance, 30 minutes. These are your labels. So 30 minutes would get matched up with a half hour. So just looking at these numbers and these options, see if you can find a few things that are equal to each other. Equivalent measures. All right, we'll just jot down a few. Does anybody have one? Jonas?
12 inches equals 1 foot.
12 inches equals 1 foot. Sophia? 60 minutes, 1 hour. Kaylee? 2 feet equals 24 inches. Hey, does anybody see one with meters and centimeters that we could use? I see we don't have an example of any of those. Anybody know what 40 centimeters would equal? How much of a meter is 40 centimeters? Look at the numbers that are options. What do you think? 0.4. Yep. All right, so there's 4 examples. Again, there's lots extra. They gave us 1, so I guess that would be 5 examples there using that. Next problem. There is a proportional relationship between any length measured in centimeters and millimeters. Just an example of a ruler here. It says there's 2 ways to think about this proportional relationship. If you know the length of something in centimeters, you can always calculate its length in millimeters, complete the table. So in order to know this, or fill this out, we would have to know how many millimeters are in a centimeter. Jada, do you know how many millimeters are in a centimeter? 10. So 1 centimeter equals 10 millimeters, and we can see that right here. Here's 1 centimeter, here's 10 millimeters. So if I have 9 centimeters, how many millimeters is that? 90. So I am taking everything times 10 going this way. So what's 12.5 times 10? 125. What is 50 times 10? 500. What is 88.49 times 10? Sophia? Yeah, I moved the decimal 1 spot. Okay, so it says complete the table. Done. What is the constant of proportionality? That means if I had a 1 over here, what number would go next to it? Or what am I taking every number times? 10. 10 is a constant of proportionality. I'm taking everything times 10. Okay, take a look at number 2. I'm going to give you a head start on this one. Now it is doing the opposite. It's giving you millimeters and it wants it in centimeters. So see if you can get that one. Kellen, you got the chart done? What do you got?
70, I think the length is 70, 24.5, 0.4, and then 69.91.
Okay, what was the difference? Instead of multiplying by 10, I divided by 10. Or that's the same as multiplying by what? 1/10. Multiplying by 10, or 1/10 is the same as dividing by 10. So what is the constant of proportionality? If I would have a 1 here, what number would you put to the right of it? Faith? 1/10. And I don't care if you write it as a decimal or a fraction. It is 1/10. Question number 3, raise your hand if you know how these two things are related to each other. Boston?
They're the same, but flip.
Yeah, there's a special name for that. Reciprocals. They are reciprocals of each other. 10 and 1/10 are reciprocals of each other. Question number 4. To convert centimeters to millimeters, that's like what I did up here. You will multiply by 10. We multiplied by 10 to get to millimeters. B, you can convert millimeters to centimeters. That was the second table. You can divide by 10 or multiply by. Very good. 10 and 1/10. Question number 1 on the Are You Ready there? Let's discuss this one. If I have a square millimeter and a square centimeter, how many millimeters are in there? So let's say I have 1 centimeter and 1 centimeter. How many millimeters make up 1 centimeter? That'd be 10 millimeters. How many millimeters make up 1 centimeter? 10. Okay, and I incorrectly drew it. It should have been the same size because they're the same thing. So how many millimeters are in here compared to 1 centimeter here? 100. Why is it? It's the scale factor is 10, right? And what do I do with scale factor when we're comparing areas? Because they're squared, I have to square it. So there are 100 square millimeters in a square centimeter. How would you convert square centimeters to square millimeters? So how would you do the opposite of times 100? Divide by 100 or multiply by the reciprocal. You'd multiply by 1 over 100. Okay? So how would you convert square centimeters to square millimeters? We did answer that in number 1. It was times 100. How would you do the other way? Times the reciprocal, or divide by 100 means the same thing. Okay, question 3. A plane traveling at a constant speed flew over Pittsburgh, St. Louis, Albuquerque, and Phoenix on its way from New York to San Diego. Complete the table and be prepared to explain your reasoning. Table must be on the next page. All right, so what is the distance between St. Louis and Albuquerque? So let's fill out the chart. This one is asking for the distance right here, so we might as well do that one first. So how are we going to figure out how far that distance is? Well, let me ask you, our speed, how fast are we flying? Yeah, you are going 550 miles in 1 hour. So how fast is the plane going? 550 miles per hour. Okay, and that's actually going to be the same for all of them. Yeah, our plane doesn't slow down going across cities, obviously, because you're flying way above it. So in 1 hour, how far can I make it? 550 miles. So the 1 hour is going to be 550 miles. Now I got to figure out how far I can go in 42 minutes. Well, how many minutes are in an hour? 60. So I'm going to take 42 over 60 and help me reduce that, please, so I don't have to work with such a big fraction. So I want to reduce 42 over 60. What number can go into 42 and 60? 6 can go into it, right? So what's 42 divided by 6? 7 tenths. So 42 minutes is 7/10 of an hour. So what do I got to do with 7/10 of an hour? Well, how far can I go in an hour? 550 miles. So I got to figure out how far I can go then in 7/10. So take 550 times 0.7, please. Brody. 385 miles. So, in this hour, I can go 550 miles. In this 42 minutes, or 7/10 of an hour, I can go another 385 miles. So that's a total of, just adding those two things together. I heard 935. Anybody confirm that when I added them up? Yes? Yes? All right. 935 miles. Question 2. How many minutes did it take to fly between Albuquerque and Phoenix? Now we're filling out this one. Well, do you think it's going to be more or less than an hour if I made it 330 miles? Should be less, right? So I can go 330 miles. And how far do I fly in an hour? 550. So I need to reduce this fraction to tell me what percent of an hour. So go ahead and reduce that. Yep. That can be reduced further. 33 over 55 can be reduced further. 3 over 5, that reduces to. So I got to figure out 3/5 of an hour So you have two options. You can take 3/5 times 60. You can make 3/5 a decimal. That would be 6/10 times 60. I don't care how you do it, but I got to figure out how many minutes it is, so I got to take it times 60 minutes in an hour. So either way, if you're more comfortable with fractions, if you're more comfortable with decimals, you're going to get the same answer. Got it, Cameron?
I got 36.
36?
Yep.
All right. That's correct. Which you told me was going to be less than an hour, so that makes sense. 36 minutes. Okay, what is a proportional relationship? That means what I'm comparing. Okay, I'm comparing the distance traveled is proportional to, what was in that first column? The time. Distance traveled is proportional to the time it took us to get there. Diego said the constant of proportionality is 550. Let's talk about that first. Do you agree with that? Is 550 the number next to the 1? Yeah. Okay, so that one looks good. Andre says the constant of proportionality is 9 and 1/6. Now, before you say no, let's kind of discuss how he would have gotten that. Yes?
I think it's like for his it's 1 minute, how many miles ago than me.
Yeah. So let's take 550. We used an hour. Let's take 550 divided by 60. We can even get rid of the zeros. 55 divided by 6. How many times does 6 go into 55? 9 times. And what do I got left over? 1 over. Does that look familiar? Okay, that's what Andre said. So do you agree with him? Yeah. But he changed it to minutes. Okay, so we did miles per hour. Andre did miles per minute. So to start this lesson off, we talked about different labels. Okay, you could have left this one. I did say distance, so that would have to be miles, but you could have left this one in hours if it didn't specifically said minutes. That wouldn't have been wrong if we would have said 0.6 of an hour. So just know that there's different labels, but if it does specify minutes, you have to go minutes. But neither one of these two guys are wrong. Those are the same thing. So you just have to watch the labels. That's the point of number 4 there. Watch the labels. Okay. Let's take a look at the summary here before I let you work on your assignment. What is the constant of proportionality to that table on 24? What number is next to the 1? 2/3. That means times 2/3 going this way. What would it be going this way? Divide by 2/3 or times the reciprocal. This one is the exact opposite of that. It's got the numbers flop. Notice how it's times the reciprocal of the one you just told me about. Okay, times 3/2. All right, question number 1. You're filling out the table, and it's asking you how far you would run at different time intervals. So you're just finishing the table. So once you know what its times going this way, which it should be easy because it tells you how fast you were going, right here, it tells you 6 miles an hour. In 1 hour, you should know how fast or how many miles you can travel, going 6 miles an hour. So once you figure out what you're multiplying by this way, you multiply by the reciprocal going the other way to fill out these 3. Question number 2. kind of filled that out with centimeters and meters on today's lesson. Now you got meters and kilometers. It starts it for you there. Notice here it does ask you what the constant proportionality is for each. What's the relationship? You can probably already guess what the relationship is going to be because we already answered that today. Okay, question number 3. Circle word explain, please. Question number 4 is asking you again for the scale. Note that it's referring to area once again. So you should know what to do with the scale factor when we're talking area. Question number 5, circle the word all. Maybe you want to put a little arrow on 27 there also so you don't forget that there's another page. So you know you got to flip it. Again, question number 5, circle the word all, and question number 6. Now, do you remember what we had to do when we talked about circles the last time? We just had one like this, right? You're going to make a chart like this. But what's different about the circles you already did compared to these? Okay, there's 2 circles. So you're going to have to make one for inner circles, width and height for the inside parts. And then you're going to have to do it for the outside parts because they both have to be proportional to be exactly the same. So again, you're going to make a chart just like this one. One for the inner circles, one for the outer circles. Comparing the width and height for L, M, and N. So 2 charts needed for that one. Notice it does say explain as well. Okay, questions?